Good evening to you all. I would like to welcome you all to the ARDC, Joint Research and Demonstration Center for Water Technology. And I'll be very much glad to Dr. Pandukar and his team, the CES staff, and all the students for having this invitation for me to deliver the first physical CES speech, CES talk. So I'm not new to CES. I had delivered a couple of in the Faculty of Engineering itself. And having again back this in physically is nice to see you all. And especially so glad and delighted to address the students coming from my university, my faculty. That's all the way there in my mind. So thank you. And the ARDC is located in front of Faculty of Engineering because of one of the most important reasons is that I am from University of Peradeniya faculty. So I wanted to get it as much as closer to your premises. And thank you very much to all the dignitaries, especially the University of Peradeniya staff, Vice Chancellor, Dean by that time, and having us here at the location. So today the talk is about the application of water safety plans, and I would like to focus the role of engineers. So if you just count the world application, so we got almost like 90 plus countries across the world who are having this involvement, implementation approach in the water sector. So WHO has recognized this as the best tool to ensure the water quality consistently. The word consistently is in engineering, we call it as 24/7 supply. So we can't accommodate, we can't appreciate any sort of interruption in terms of quality or quantity. So that is what WHO is all the way focusing and emphasizing the importance of WSP. So I'll just get you today almost like 40 minutes of my presentation and probably another 10 to 20 minutes the follow-up discussion. So I thought of discussing the state of the WSP in Sri Lanka, where right now we are. And what is WSP? That's the most important for all of us. And it's not just talking about water, it's talking about engineering, talking about the professional applications, the management tools, and a lot to come. Then, how do we, as engineers, to assist in this process? Those are the three areas that I would suppose to cover. I hope that it will bring a lot of insights. So I'm so glad to present this map of the world, that because when you count the year 2015, so you find the Sri Lanka is counted as no WSP implementation. But when you get this in 2020, so Sri Lanka has been promoted almost near the world developed countries. So as I said, many countries they are implementing WSP. Some countries like USA, they do not count WSP as in that term, that terminology. They have a different approach, but almost following the same concept. So then we were counted at WSP policies or regulations under development. The development in the sense we have already included this into the acts and policies of Sri Lanka. And next, the map will include Sri Lanka at the topmost level in parallel with the developed countries. So this achievement did not come. It's just not the just a normal way of achieving. Like I want to highlight here the contribution done by various employees, professionals coming in water sector. So thank you to the national NUS, National Unit of Singapore, and PUB, Public Utility Board in Singapore. So they are the first people to come and teach us WSP concepts in 2011. So there onward, I had a chance to get into IUTC in South Korea, and one gentleman called Chris Underwood from UK. So he is the guy, the gentleman who taught us WSP in South Korea. So I got one sociologist and another engineer, very prominent engineer from Sri Lanka, together with myself to represent Sri Lanka in 2012. Then we had training in 2013 in Bangkok. the assistant from the Metropolitan Water Authority in Bangkok, then the WHO experts. Then we had another training in India. So coming again back to WHO experts plus NEER in India. So that's enough wonderful place for training like this. So this whole journey took us a lot of confidence, lot of confidence, and made us very, comfortable in putting up this concept in Sri Lankan soil. So there onwards, we had a team representing geologist, sociologist, chemist, and myself, and I am the head of the unit that's called Water Plan Advisory Unit. So recognizing our contribution in South Asian region and the Southeast Asia region, so the recent revision of WHO manual, which is done for the world, has been sent to me as a reviewer, giving the value for us, whatever that we have done, recognizing that as a Sri Lankan. So I'm having the privilege of presenting here that ideas, whatever the lesson learned, we had as a team, National Water Supply and Drainage Board, Ministry of Water Supply, together with other partners. So then all this story is being documented in 2020 in a document called A Journey Towards Safe Drinking Water for All. So where we have got the feelings, thoughts from different experts from the world who got involved with Sri Lankan chapter to put up this WSP. This is available in IWA, National Water Association portal. And the two gentlemen talking about here, one Mr. Asoka Jayaratna, he's an engineer, professionally graduated from University of Peradeniya, very senior gentleman now working in Yarra Valley, Australia. He's one of the teachers to us. And I would like to appreciate himself, plus Mr. Daryl Jackson, again back an engineer working in Australia, as an expert in WSP, especially working for WHO. So these two gentlemen who taught us these concepts at the very first time in Sri Lanka and India as well as Thailand. So giving thanks to them, we had a wonderful journey, and all this will be accommodated, absorbed by the water sector in Sri Lanka. So there's a real need of having a sort of tool, vigilant, very practical tool to come and apply, implement in water sector. So the map on the left-hand side shows where right now the water supply in Sri Lanka. So we got about almost 50% of the population fed by through 332 water supply schemes across the country, having 2.2 million of domestic connections plus another couple of 100,000 of commercial and other connections. And we got almost laid 40,000 of kilometers of water pipelines, either coming as PE, DI, PVC, or GL. Then the target of Sri Lanka to make it as double, to bring the coverage of 50% to almost 85% of the total population in the country. That regards, the map will be the same, whatever that given on the right-hand side. So then in regards of making a reliable source, reliable supply, reliable service, as per the vision of the National Water Supply and Drainage Board, to be a prestigious service provider in the country. So there's no other tool other than going with WSP. So we'll be having almost 4.5 million of connections, and all whatever flowing through the network, through the distribution, transmission, will be getting assisted by the WSP tool. That is the beauty of this WSP, which is very strong, very robust mechanism to ensure the water supply consistently throughout the way. So that is the idea. This is what the vacuum, that is what the need arises from this water sector. So all this to come, all this to go with, we got two documents available in internet. You can download through the WHO website. So that's called as Water Safety Plan Manual, step-by-step approach for risk management. Or else we have another document called Water Safety Plan for Small Water Communities Water Supplies. So when you take the main document, so that is for the urban sector, which consisted of 11 steps, or we call them as modules. So the other is for the rural sector, where you don't find that much of expertise, you don't find engineers, geologists, chemists, and socialists to come and work in the rural sector. They are the community people. For that, we got a same methodology, same receipt in a different way called 6 tasks instead of 11 modules, but the concept is same. So this is what that we find as the references for you. So if you want to learn, this will get you a lot of insights. And WSP, since it is recognized in almost 90 plus countries around the world, so if you are planning to be in water sector, if you got qualified in WSP concepts, this will be a really nice avenue. You'll find a very good room for you to secure a job in abroad. That's I'm very sure, because I got a lot of feedbacks from the people working in abroad, especially from Australia, New Zealand, and other couple of countries. So they are so much happy to get engineers who are capable of talking, implementing, working in WSP, because this is recognized well in the world. So what is WSP? So there are different definitions, different thoughts about this. One of that WHO guideline, drinking water guideline, which is the document for whole world to put up their standards, telling that in the 3rd and 4th edition, the most effective means of consistently ensuring the safety of a drinking water supply. That's getting a lot of. So it says you might get other management concepts like ISO 9001 or other manufacturing process protocols and so on. So, but when you count ISO 9001, we as production engineers or the process engineers, we find that ISO 9000 is given for batch processes. It might not support you to go with a continuous process. You understand what is the difference between. So if you got a batch process, you will get the raw material. First, you got time to certify, go through all the testing and certify that for the whatever the standards, and you might see whether they are getting complied. But what is not like that? You have to go with the continuous supply, and you have to get 24 supply, and the water results, test results coming for bacteriological like E. coli, total coliform, will take minimum 24 hours to get the results. By that time, all the water is being pumped into the system. That's making huge damage if you got failed. So if you got contaminated, you don't find a chance to go and stop because it's been already passed and people have already consumed. So WSP is the only tool in that scenario to come and work for us. Then in other terms, they call the WSP approach is not a recipe that need to be followed rigidly to achieve success. There's no rigid, fast and fixed rule for us. It's very flexible. So you can make anything that you want, but you have to be in the basic frame of WSP. So it should cover the 4 zones coming from catchment, whatever is very complex, because you find a lot of urbanization activities, industrialization, and all this happening. And on top of that, now we are facing the climate change impacts coming. And Sri Lanka is recognized as the 2nd most affected country in the world in climate change adverse effects in 2018. And I think it has been ranked as the 6th most affected country in the world. So the loss is huge, billions and billions of dollars. So that regards, we can take this as one of the best tool. It is meant to be the flexible and adapted to the local needs. This is the other feature I would call here. So if I take why WSP, so whole world we find around 5 million children mostly died. They are the vulnerable groups because of the waterborne diseases. So if you count like developed countries, even they experience the same. So this is the story coming from Walkerton, that is what you call as one of the cities in Canada. It's almost like 1,500 kilometers away from Toronto capital city. So how they have faced this. This was a eye-opening event had in world.
அதுல அப்படி திருப்பிட்டு
Yeah, so this was a sort of eye-opener for the whole world. It's happened in Walkerton in 2000. So these initial investigations for these tube wells were done in somewhere like 1970, end of 1970s. So then later the medical experts were not so keen about putting up the wells there. But unfortunately, the water engineers, the water authority has gone for the construction. They laid the pipes and they have given the water supply. But somehow all this happened in 2000 later. So the affected uh, the manure, the cow dung came from the all these washouts to the came to the wells and then water were pumped. By that time, chlorine was not in operation. Chlorinators were not in operation. So finally, almost 2000 around people got hospitalized and 7 died. So this was a incident which is called as wake up call for a whole world. So this can happen anywhere in the world. So that is what it is coming as something very serious. And the UN has declared that having access to safe drinking water, clean drinking water is a basic right of all the human beings. So safe drinking water, how you can make it happen? There's no way other than putting up WSP as a tool. So the WSP getting in line with the SDGs and not like MGDs. SDGs are all the way interconnected. So if you go and try to focus one of the SDGs out of 17, other one we will be penalized. So we have to get all the way, all the 17 SDGs in one ring. Then WSP will come and play a big role here, because otherwise it might not be that easy for us to handle these all interconnected goals. So that is why UN has declared this as a human right. So we have to address, but still there are a lot of people who are suffering from having no access for safe drinking water. That is why WSP, that is what WSP and so on. So this is a step-by-step approach, as I said, starting from the catchment, then going through the treatment plants and distribution and consumer level. And this is a cyclic process. So you see that there are a couple of cages given as naming modules. Module 1, assembling team. Module 2, describe the system. Module 3, hazard identification and initial risk assessment. Module 4, control measure and risk assessment. Module 5, implementation plan. Module 6, control measure and monitoring. Module 7, verification. Module 8, the management procedures, and module 9 is supportive programs. Then module 10 and 11, reviews and incidents. So reviews bring up a lot of avenues for us to go and see, look into our system. This is a cyclic process. It's a never ending, but all the way you are finding, you are observing, experiencing matured WSPs. When you go to Australia, they got a very mature system. That is the only tool that they are using to ensure water quality in Australia. So if you go to New Zealand, they are doing the same. When you get to Philippines, they are still doing the same, because in Southeast Asia, they are very much vulnerable for tornadoes. They got a lot of cyclones coming. So they found WSP is the best tool for them to address this all incidents happening. So these incidents are given a room in the module number 11. So I'll take you all into these steps, and the module number 1, assemble the teams. This is a collective approach. You can't just go alone. You have to bring up all the different expertise. So not like just water suppliers, but the catchment come in with the local authorities under their control. All the legislation, there are about 40 plus legislations in the country for ensuring safe water through catchment conservation. So in regards to, if you want to implement, if you want to empower this implementation in the ground level, this is the choice. We have to go with that. So then we have to call RDSA that, because we have all our pipes going along in our RDA roads. Then RDS being shared with telecom, CB, and other service providers. We have to call them as well. Then the health authorities, medical experts, they are the people who knows, who get the information about the health aspects. So that is there. So then water quality experts and other agencies, even the police. Police having a unit called environmental police. So then we can call them. So engineers, technical staff, all the way they have a big role to play because engineers and other professionals, as I said, like geologists when you get groundwater, then chemists when we are talking about water quality, then sociologists when we are working with the society. So we have to call this expertise. On top of them all, I would like, there's a one edge that for engineers. Because this is just not like supplying water. We need to understand what you are going to supply, how you are going to bring up the existing water quality to comply with the standards given in any other country. For Sri Lanka, it's SLS 614. So that regards, we have to go and see the unit operations and processes. Once you bring up this all, we call as the treatment train. You need to happen it. So we need to bring a lot of expertise. So as I said, there are 4 zones: catchment, treatment plant, distribution, and consumer. So module 2, system description would tell about the all hidden secrets behind this. This is what I have done as the chief engineer, the design of Greater Dambula Water Treatment Plant worth of $78 million US. And over there you see for that the corner that the water source was, that is Ibrankadu reservoir. So this reservoir is being fed through the Mahaveli water supply system. We got diverted that Polgolla, it's been passed all over the way into North Central province, and this is a sort of transit reservoir. So then what is the water quality that you are experiencing? How about the inorganic, organic pollutants coming here? So how about the physical, chemical, bacteriological behavior here? So we need to have that understanding. So definitely once after getting this all information on your table, you have to go for the process design, which is somewhere like we need to get engineers. So process engineers to come. So they have to go with all this design component. So then once you do the process part, we have to call the mechanical engineers, electrical engineers to come and place all the M&E requirement, mechanical and electrical requirement. You get a lot of pumps, you get a lot of sensors, you get a lot of valves, and these all are automated. You get the communication from the intake, which is 600 meters away from the tank, Bankadu, and we got communication through the optical fibers. Then everything we can operate, we can observe by being in the control room over there. So then once you get the water, you have to go through the treatment step by step. In order to put up this all, we need to have civil engineers to come and play a big role. Structural engineers plus civil engineers, geotechnical engineers. So all this come in, then the job will be done at the treatment plant. Then distribution is coming, transmission is coming, reservoirs are there. It's a big job, big task for all whomever coming from civil engineering, chemical, mechanical production, electrical, and all discipline, computer as well coming and playing a big role. Then consumer level. That's also even that's coming as a challenge, because now in Colombo, like we are going for high-rise buildings, a lot of things that we have to consider in regards of managing a different sort of supply to high-rise buildings, because we have to maintain water quality and quantity at the same time. So looking into this all, the module 3 is coming. That's called as the hazard identification. So as I said, so basically we find physical, chemical, bacteriological pollutants. So there will be thousands and thousands of chemical coming in our water, which is spread all over the catchment, getting filled with catchment water. So coming back into a treatment plant, we might be able to remove some of the chemicals, but still there could be something passing through our systems. So we have to be very vigilant on that. So we have to promote some controls at the consumer level. We have to promote some controls at the distribution. We have to have our overall collection of controls at the treatment plant. Plus, still we need to have something in the catchment. That is the responsibility of the polluters. So CEA, Central Environment Authority, is the responsible party in Sri Lankan context, like US EP and USA. So they are responsible to ensure water quality. So they are responsible to ensure the treatment process happening as we are planning. So otherwise we can't bring all the things back into treatment plant. So the environmentalists, all our other experts should get into the catchment and see whether they are the treatment, wastewater treatment plants are in operation. That regards we need to have engineers, definitely engineers. So the other experts as well in line with them. So this is how that has been done. So then once you recognize all the possible hazards, that what we call as the big players, we have to address them, we have to handle them, we have to control them. That's regards we have the control measures. This is what we call as the control measures. So control measures should be capable enough to control over the hazards happening in these 4 zones. If not, you might not be able to supply water. So if I just take one country like Japan, one of the cities, world 4th best livable city, is coming as number 1 Austria or Melbourne, vice versa in Austria from Vienna city capital, and either Melbourne coming as 2nd, 3rd somewhere, then 4th is Osaka. So Osaka, the mayor is the responsible person for supplying drinking water. He has strictly advised, you must not go for water supply if you got anything coming as a hazard, which is not under control of water supplies. So he got a risk matrix. That is what the tool that he is using there, his employees are using there. We do have the same here in WSP application. So if you got marked anything as red, you have to immediately go and stop water supply. But they have the network connected in a loop, so they don't want to supply water supply totally to the consumer, but they can get water from some other sources, some other suppliers, while attending on the issue that they count in the system. So then the 5th is the improvement plans. So improvement plan is totally an engineering job. It's like that you are going for different techniques, different controls, different mechanisms, coming with mechanical applications, electrical applications, telecommunication, all the way. So when I was there in the water treatment plant, just opposite to the Faculty of Engineering, we are using somewhere like 485 megahertz for our telecommunication. We're just communicating through almost like 15 reservoirs around this area. So you can just operate the plant having only one single operator if you got prepared your chemicals. So how the role, how the responsibility of telecommunication engineers to come and play. So we could not run the facility at the very first time because all the transmitters got overloaded because of the data transmission. So then it was almost 400 times overloaded than the normal. So we got our engineer to get into Australia. The transmitters we got from New Zealand. So he has been trained, and within a short period of time, we could arrest the problem, and we just managed to reduce the data load, the data communication, and that is how we have done the commissioning of the treatment plant, just opposite of your faculty, Candice. So this is what the role of engineers. There's no other way for us to run. So we got about 71 sensors in Candice treatment plant. And while I was working as the plant engineer, I was so keen to manage all 71 sensors on live. They should deliver the service. Okay, so we can't just compensate one for any other reason. So that's the responsibility of engineers, mechanical engineers, and others to come and play. So this is what. So when you are thinking about a sort of an improvement plan, all disciplines should come here. Not only engineers, but other professionals. Like as I said, if you are going with groundwater, geologists come and do a great role. They have to play a great role here. This is how it's done. So let me move. Once you got these improvement plans done, then thereafter, WSP, complete picture, we have to control, we have to make sure whether all controls are in operation. So it's just not like a simple job. Rather than just going and looking into the treated water quality. As I said, treated water quality will come after 24 hours. And you are just sending only 0.01% into your laboratory and you are testing. Rest of the water, 99.99% is being delivered to the consumer. It's been already consumed. So 0.01% will not be a representative enough to get the real water quality, real picture. So instead of having water quality testing in laboratories like this, we have to go for the control measure monitoring. So all the controls, if they are in my catchment is in control, if they are controlling the assets, then we are sure that water is safe. If you ask me, is the water at the in this tap is good for consuming? I should ask that, is the control measures are effectively working now? If so, I can tell you can consume. I can't just ask someone to go and test your water because that result will do nothing for us. So that's the question someone would ask. After doing this all monitoring throughout the way, we should have to have a sort of mechanism to verify our results. So WSP providing us a room in module number 7 called verification throughout different ways, different mechanisms called compliance monitoring. That is what we are doing with laboratory testing, SLS 614 or WHO guidelines. Or for Sri Lanka, some parameters we are going with US EPA as coming as something solid for us. Then audits. So we do have auditing done now in Sri Lanka. There are 4 formats for us to do audits: internal, external, formal, informal. So Australia having their set of audits as independent audits for formal independent audits. We have done this in Sri Lanka for the very first time, having the support from IESL. Since I call IESL that because they are one independent agency, anyone can trust on them. And we got registered the experts who got experience in water in Sri Lanka and abroad, come and work as an independent auditors. So they have a role to come and play and certify our water supply by having a very stringent sort of mechanism called WSP auditing. We got another manual for that. So then consumer satisfaction survey is another one very important for us to see. So finally, we should consume water. That is the most important thing. That regards, we are going and doing a consumer satisfaction survey. We got just city like Bangkok. The whole population in Bangkok city is about 12 million. Only 4% of the people out of 100 is consuming water directly from tap. That is the situation. That means that they are not that keen about Bangkok metropolitan water supply because they are not that confident about it. But in Colombo is much more than, in Kandy is much more than. So I do consume directly water from tap. So Mr. Aranda with me, our assistant general manager. He was the former manager for this Kandy South area. So we all having the confidence about our water. So that because we are applying WSP, so we are confident about that. We try our best to keep our controls in our hand. And that is what. So verification is a process that we are doing at the end of the year, probably to see whether we are doing all our operations in a recognized manner. In order to happen this all, we have a platform called procedures and programs. So we have to have management procedures and supportive programs. So if this all are in operation, management procedures like selecting chemicals, purchasing chemical, going for procurements. So procurement again back part of engineering job. We do have procurement experts, but it's still engineering, tendering and all is coming in that way. So very recently myself and Mr. Randa, we had a team to go and do investigations about the alum, lime quality, the suppliers, whomever they're getting us. We have to ensure whether they are complying with our standards kept for this alum and lime person. So that's regards. That's again back. We had a couple of testing done here. So this is what that we have to do. Even the recruitment, even the training, all the supporting and management procedures will bring us a sort of confident staff to run these facilities. So WSP is so keen making this as a platform that because otherwise you will not be able to get the solid supply to you. So then the last 2 modules, 10 and 11, is putting us the review and incidents. So reviews that because if you got the system changed, if you got revised your procedures, new SOPs to come, staff changes or stakeholder changes, verification records, operational data and trends might help you to go for reviews. So one good example happened in Meetotamulla case. So we as a National Water Supply Agency, so our engineers who got applied WSP got into that Meetotamulla area and they found that there could be a possible landslides. So they just foreseen that and they immediately took actions and replaced their pipelines. Otherwise, the disaster could be even more than whatever that we have experienced. So that is what the reviews and incidents will help us to come up. So I'm so happy because the engineers in that area, Corona area, were so keen and they were very smart in applying what's the plan in the country. One of the leading team, thanks to them, they made proactive approaches to handle this issue. So we could not have any sort of interruption after having this the landslides. So that was something good. So what is this WSP? What it has to come? So that is one role that the WSP is getting as one prominent because of the climate change. As I said, there's a big role for us to play when you see this climate change happening. So let's see what's this about.
When you think about water and climate change, you probably think of headlines about rising sea levels. And you're right. In every conceivable projection of our changing climate, water is the hidden variable that many don't consider. The world's driest regions will get drier under most climate change scenarios. Parts of Europe, South America, Africa and especially Asia are facing reductions in runoff. Without action, this means potentially enormous effects on the available water. And many large urban places like Manila, Mumbai and Mombasa are located in areas prone to flooding. Add in paved floodplains, deforestation, trash-clogged drains, and the flooding risk grows larger, especially in cities where millions of people live in slums. And don't forget that cities and industries run on water. Energy needs water. When water is scarce, businesses shut down and jobs disappear. And history shows that water scarcity causes conflict and migration. Under a business as usual scenario, water shortages will severely hamper growth, particularly in Africa, the Middle East and Asia. But it doesn't have to be the case. With good policies and practices, many of these effects can be neutralised. We can't control how much rain falls, but we can control how water gets used and move towards a world of resilience in the face of a changing climate.
Systems as resilient. So that is what this video is discussing all about.
When you think,
yeah. So in regards of the role of engineers, I just thought of highlighting 4 areas here. One is the system description. So whatever you see in the catchment, you should be able to go and describe. You should be able to go and realize that regards, so you understand all these activities, urbanization, little bit ad hoc it's happening. We don't find siting, policies for siting of industries. Anyone go and do siting, go and go with the, whatever the business commercial interventions. So that brings a lot of pollutant to us. When you take the organic chemicals, there could be thousands and thousands of chemicals. So how we are going to understand, how we are going to realize, how we are going to bring up the whole information. In that regards, I mean, engineers having a big role to play. So it's very complex. So even the water management from Kotmale to Victoria, how many engineers, how many entities are getting involved? Kotmale having 3 gates which are being automated, different to the water level, they are being operated. So last couple of years, we had experience of having operated these 2 gates, they got open. So then the water level being increased, the downstream, it's been impacted over Polgolla. Then the Polgolla backflow is coming all the way. So a lot of engagements coming. So we need to understand the water quality as well as quantity. So moving towards the control measure, as I said, it's just not like putting up anything. If you are doing perfectly, you have to have a very strong understanding about different controls that you can go in. So smart concepts all the way begin, like K-Watt in Korea, South Korea. So they have got 167 rainwater gauges in their catchment. It's been all connected with the cloud system. They are having a mechanism to go for real-time observations and putting up these all trends, and they are making a sort of a smart approach to make trends, look into trends and getting decisions made by the systems themselves. But all the way we have to control, we have to observe, we have to be alert on whatever the decisions they are making. So that regards the control identification is something so important. So it's recognized right now. Every 1 minute we are putting up 280 smart the sensors for going to the smart systems. By another 5 year times, we'll be having almost 75 billions of sensors kept around the world. So this is the number is coming up. So these all are for different sort of approaches. Out of this all WSP, I really like to see this risk assessment, which is one of the very, very important, not just for WSP. Once I was in Dubai for some other reason for actual teaching. Then I had a guy from UK and I was just talking to him and asking, all these Middle East countries, you find a lot of Europeans working as experts in this project management. I asked, what is your tool? How do you manage the project as? Like, then he was telling me, just minimize the risk connected with all the activities in his master plan, activity plan. So if you can minimize all the risks, then so automatically you are delivering the project on time without compensating quality and cost. That is the approach. So risk management is coming into a research. Research also, I do ask my students to go and do the risk metrics. So the same risk metrics, calling for the consequences and likelihood. Likelihood is the frequency, consequence is the result. So if you can manage the risk, all whatever coming in green zone, that will be delivering the final results as we expecting. So this is a tool that we can get involved. Engineers can play a big role. Some mathematics is coming and playing here. Then finally, as I said, the improvement plans. It's not just in catchment, but treatment plants, distribution, and all that we have to see. Engineers again back deciding is in our own hands. So a lot of engineers coming and involving. That is what we have to come and see. So very recently, engineers got together and they have done a sort of virtual commissioning of a sort of facility like this. Let me see this video. That should I check all this, but change my computer probably.
Hi, and thanks for the opportunity for us to share our innovation moment with you. What you're going to see is a demonstration of augmented reality technology being utilised at a recent stormwater harvesting site commissioning. You'll see it demonstrated live in the field and also get an idea of how we see it being used into the future.
Here's a quick recap on what the difference between VR and AR is. Virtual reality is the practice of putting yourself fully into an immersive digital environment, whereas augmented reality is the practice of overlaying digital content into the user's vision.
So he's talking about
Looking
the
at several
virtual
augmented reality
situation.
solutions,
You
we
can't
had
call the
decided
people.
on either using the Microsoft HoloLens 2 or the RealWear HMT1.
Hi, and thanks for the opportunity for us to share our innovation moment with you. What you're going to see is a demonstration of augmented reality technology being utilised at a recent stormwater harvesting site commissioning. You'll see it demonstrated for us to share our Hi, and thanks for the opportunity for us to share our innovation moment with you. What you're going to see is a demonstration of augmented reality technology being utilised at a recent stormwater harvesting site commissioning. You'll see it demonstrated live in the field and also get an idea of how we see it being used into the future.
Here's a quick recap on what the difference between VR and AR is. Virtual reality is the practice of putting yourself fully into an immersive digital environment, whereas augmented reality is the practice of overlaying digital content into the user's vision. Looking at several augmented reality solutions, we had decided on either using the Microsoft HoloLens 2 or the RealWear HMT1. Both have their use cases and their pros and cons. In this case, we've selected the RealWear HMT1 because it is a rugged, field-ready device with a long battery life, suitable for operations out in the field. You can see I'm wearing one now. Due to the impacts caused by COVID-19, Microsoft have been working with RealWear to integrate Microsoft Teams into the RealWear HMT1 headset. This option was only available for those with high-value COVID-19 use cases. Through our account executive, Jen Ribeiro, we were able to get accepted into this program to trial MS Teams on the RealWear HMT1 headset that I'm wearing now.
Hey everyone, just a bit of an after action report on using the AI headset for the stormwater commissioning. While their technology is great, it made it so easy to talk to everyone online. Basically looks like a Microsoft Teams call from what I'm looking at, and frees up my hands to do what I need to do on site. If I didn't have the headset, I think I'd be having to hold 2 phones for different conversations and have a laptop on the side looking at my SCADA screen. But all that came up on the headset, and that was great. The headset itself, it's really light. It only weighs probably the same amount as a hard hat would. It was very easy to use, and as I said, it frees up my hands. And so I could see everything that I would usually be able to see in the office, and made it a lot easier and quicker for everyone else to do their part. If you're an electrician...
This is Tom, sorry to interrupt. You can share your screen if you want, and then Aaron can see your screen if it's different.
Oh yeah, okay. Didn't know that Aaron can see my screen.
You may need to just zoom in a little bit.
I can see all the figures. So you've got two valves.
So you see that two valve? One
valves. Right, so there should be two potable valves, but there should also be a non-potable valve. And I'm thinking it's on the far right-hand side of your screen.
Usually there will be minimum 4 subject matter experts to attend site for the commissioning like this. One for operation, one for maintenance, one from safety team, and a project manager. The AR technology has helped to close the gap between on-site commissioning officer and engineering support from the office. The live stream videos have helped to provide a clear vision of all assets installed on-site, which helped me to identify any potential defect from a safety, operation, and maintenance point of view. It definitely has helped us to complete all testing scenario quicker and with great confidence.
Can you go back to the cabinet before and look down at the contour? Yeah. Look down in the orange contour. Are those sealed with the expandable foam? Those need to be sealed. If it's not,
are they sealed?
Yeah. I don't think so.
Doesn't look like it.
Yeah. So put on the note there, they need to seal it.
Yes, so that's all happening now. When we were commissioning the plant over there, we had experts coming from Europe and India. When we were doing in Dambulla, in fact, we got physically, but we don't want to get it physically there. So this was a commission of a stormwater management facility, same like water supply scheme. So all this is happening because of the involvement of the engineers. That's what I do find like this, especially putting up these technologies into countries is something in the hands of engineers. So we right now here in this premises called JRDC, Joint Research and Demonstration Center, we are having these all facilities. Luckily, we got the very first foreign researcher coming from USA, I suppose, to stay with us now. He's using our accommodation in the facility, so we got good quality facilities, and any one of you can hire this. It's very reasonable price, and even for personal visits, you can use the facilities over there. We got about 14 rooms for 20 people at a time, and we got the lecturing facilities, and on top of all, we have 1 billion worth equipment over there in right hand, left hand side over there. So, and behind is especially done for engineers to go and test their pilot technologies. They can pilot their all the whatever that they are getting as the equipment facilities, and we have one our engineer doing PhD right now attached to cars, working on wastewater, having this pilot system over there. We are hoping to come and bring a lot of other facilities in the future as well. So this is what I want to wrap up now. So role of engineers is something very important. So engineering is doing something beyond the normal people based on the unrealistic, unreliable data, maybe to a certain level. So if engineers, we as professionals with other professionals, we have to go with a CPD, learning, experience, having abilities, developing growth and advanced training, competence and knowledge, all will bring us to make a good world for the future society. Thank you very much, everyone. And I hope that you enjoyed the presentation. Thank you very much.